Good morning, Year 12 Physics students. Today's work is going to be on forces. Just drawing a rat here, which I've been working on over the holidays. So far we've killed 29 with our trapping program. And what we'll learn about forces is the difference, firstly, between mass and weight. Mass is measured in kilograms and weight is measured in newtons. So all forces are measured in big N for newtons. Mass is measured in kg, so it does not have a direction. It's a scalar quantity, whereas a force is a vector quantity. If we were to label the forces on this rat, there'd be one going down, which is force weight. There'll be a force going up, which for this rat is going to be equal and opposite. So the length of this vector is going to be the same as that one, and that one there is force support. And then we've got our rat, which we'll just say this rat is going forward, and we'll draw that one there as force thrust. And then there's going to be some friction because this rat's got a fluffy coat and he's got some whiskers sticking out. He's got a bit of drag, a bit of air resistance as he moves through the air. So pointing towards the back of the rat, which we'll just draw over here, keeping him away. And we're going to make this one a little bit shorter. So if we make the length of that one there shorter than this one, I'll make it a little bit more obvious, make that one longer. This one here is force. It could be force resistance, could be force drag, we'll call it for this one, drag force. Now, because this one is shorter than that one, that tells us that the thrust force is greater and therefore this rat is accelerating in that direction there. Now, if we carry on page 156, it gets into some calculations using this formula here. F is equal to ma is what it is. It's the universal formula for force. And mass is in there because it matters and acceleration matters. So this tells us that if we've got an object that experiences a large force and has a small mass, then it's going to end up having a large acceleration. Alright, because this times this has got to equal that. So if this one's big, this one would have to be small. If that one's big, then that one would be small. So we can think about it like that. On this page, though, it's going to be a lot of it is working with specifically weight force. So in weight force, the formula just gets modified to be force weight is equal to mass times gravity. And the G value depends on the size of the planet you're on. So if you're on Earth, gravity is equal to 9.81. If you're on the moon, for example, it's only G is equal to 1.6. And that's because the moon's got significantly less mass than what the Earth does. And the other one they've got in the book is Mars, which is 3.7. So it's somewhere in between as far as its mass goes. So mass determines the acceleration due to gravity here. Now we go on to trying a formula. So if we wanted to find out what was the force weight of this rat, the rat is 120 gram rat, this one, and he's on Earth. We don't need to write the unit in there, we can just go, so we'll write the formula, force weight is equal to mass times gravity. He's on Earth, so it's 9.81 is our special constant we use because he's on Earth. Now, our problem here is that I've put the mass in as 120 grams. For all of these formulas, they've got to work in kilograms. So we've got to change 120 grams into kgs. To do that, we just got to divide it by 1,000 and put our decimal place there. So we're going to work out force weight is equal to 1.2, which gives us 1.177. And you can see that we've got 3 significant figures there. We've got 3 there. So therefore, our overall answer for the weight of this particular rat is 1.18 newtons.